Okay, so just now we already explored the how do you calculate the coordinate of a stationary point. So right now we're going to explore the nature of stationary point. So there are three types of stationary point. So there are three types. Okay, the first type is the minimum. So that will be a small graph. The second type is the maximum point. Maximum point will come from a set phase graph. Okay, and the special one will be the point of inflection. Point of inflection is something like this. It's the point that is like somewhere in between. So it can either go in the up direction or it can go in the down direction. So that is called the point of inflection. In your E-math, you will have seen this already. So in your E-math, right, if you try to sketch something like 2x cubed under your power function, if you still remember your power function, the cubic graph. So in your E-math, right, if you try to sketch a cubic graph, it is something like this. It looks like a snake. So this one is the point of inflection. But we do not use such a term in E-math. So you just somehow know that you're going to snake your way through when you're doing the power function. But there's actually a name for it that's called the point of inflection. So if we would like to determine the nature, we got two types of tests to use. We can use the second derivative test, meaning when we say second derivative test, right, means I will use the formula for the second derivative. So sometimes we'll be using the first derivative test. Okay, so when do you use the test? If they didn't specify the test to you, you decide for yourself. Okay, but first of all, we got to know how to do both tests first. So I'm going to roughly run through the idea, then before I show you a numerical example. Okay, so for the second derivative, right, obviously you must get the second derivative first. That means you must be able to get a formula. Okay, by the time you get your second derivative, you already gotten the x coordinate of the stationary point. So when you set dy dx equal to 0, you should already gotten a x. So maybe I call the x a triangle. So you already gotten the x. So you are supposed to put the x into this formula. So you put the x that you gotten from the dy dx equal to 0 into the formula. When the second derivative is a positive value, then it will be a small minimum point. If the second derivative is a negative value, then it will be a maximum point, a set phase point. If it's not positive or negative, it's exactly equal to 0, then that will be the point of inflection. So in the case where it is a point of inflection, usually you need to tell the shape by doing the first derivative test. So the first derivative test can actually tell the shape. So later on, I will show why it can tell the shape. Okay, for the first derivative test, it's actually not so friendly because you need a table for every x coordinate. You actually got to create a table. Okay, so for example, you already got the x coordinate from the stationary point. I'm going to use the triangle. So you got to create this table and you put the value inside this table. This value is going to substitute inside dy dx. So dy dx is your test. So you got to sub this value inside the test. It should usually give you a 0. Okay, 0 means horizontal gradient. Okay, then the next one, you actually got to get a value that is bigger than the triangle, slightly bigger than the triangle. Okay, so later on I'll show you how do you get that value. Okay, then you put the value inside here, inside the formula, and see what kind of gradient that it give you. When you put it inside, if you get a positive value, the slope is going up. Okay, so let's say we get a positive value. So that will be the sloping up. Okay, so if you get a negative value, then it will slope down. Okay, so I'm just guessing, let's say this is a positive dy dx, then it will be a sloping up. Okay, then the next one, you got to find a x value that is slightly smaller than the stationary point. Slightly smaller. And then again, you're going to put it inside. So if you put it inside and you get a negative value, then it will be sloped down. So if you look at the direction of the arrow, can you see the direction of the arrow is going down, horizontal, and then up, down, horizontal, up. So actually this one is a minimum point. So we will be able to tell the shape just by looking at the arrows. So the difference between the first derivative test and second derivative test is first derivative, right? You will be able to see the shape. From the shape, we can directly tell the maximum point or minimum point. For the second derivative, there's actually no shape. So you got to memorize the indicator. So the positive second derivative means minimum. Negative second derivative means maximum. So second derivative doesn't help you to visualize. Okay, so I'm going to put everything, the stationary point, nature of the stationary point, into a proper example. Okay, so I'm going to put everything in a proper example. So in example 3, right, we got a curve equation, and the question is to calculate the coordinate of the stationary point, and we are supposed to determine the nature. Okay, so I got the curve. So I need the stationary point. So I will need a dy dx. Okay, so for the purpose of stationary point, so focus on the stationary point first. You let dy dx equal to 0. Okay, I will not be solving this for you. You can try the solving. Okay, so if nothing goes wrong, you will get a half. You will get -3. And if you return this to the curve, return this to the curve, return this to the curve, you should be able to get y equal to, okay, I already calculate the answer of this, and you get y equal to 83. So the full coordinate will be this and this. Okay, so at this moment, I only know that they are going to be a turning point. I wouldn't know the nature. I wouldn't know whether they are maximum, minimum, or inflection. So I'm going to show the idea of using second derivative. Second derivative means I got to differentiate one more time. Make sure you use the correct test. So when I differentiate, this is my second derivative. Make sure you got no careless mistake. And there are 2 points that you will need to be testing. So if you're going to test this, you test by putting the x into the second derivative. which is quite easy. You just have to sub in and punch calculator. And if it turns out positive, then the conclusion will be it is a minimum point. You need to remember the conclusion. So it's quite easy. Just sub the x inside. So I got another point to test. So if I would like to test the other point, I'm going to sub the -3 into the second derivative. And then I punch calculator. In this case, I got a negative value. That means the conclusion will be this is a maximum point. So the second derivative is pretty easy to use, unless it's very, very difficult to get the second derivative. So there are times that it's very difficult to get the second derivative. Then I wouldn't advise that you actually go and do your second derivative. Okay, so when it is very difficult to get second derivative, that means usually the first dy dx is already difficult. We wouldn't try the second derivative test. So how does the first derivative test look like? So just now I already kind of summarized the idea of the first derivative test. So if I'm going to use the first derivative test, I need to create table. So and each point will have a table. So let me write down my test first. So this is like the test formula. So I will need a table for each of the points. So right now I got 2 points. So I got 2 points. So I need 2 tables. So I will need the x equal to half. So remember just now, where does the half go to? The half will go to dy dx. So most probably you're going to get your dy dx as a 0. Make a guess why. Why you put x equal to half, you surely get a 0. Don't forget, you get half by setting dy dx equal to 0. The half came from dy dx equal to 0. So of course, if you have returned the half to dy dx, it would have been a 0. So just now I mentioned that you got to use a slightly bigger value. So 0.5, a little bit bigger will be 0.6. So you put in 0.6, punch your calculator. I'm not interested in the value. I'm only interested whether is it positive or not. So in this case, if you go and punch it, you'll get a positive value. That means the gradient is going up. And this is a horizontal gradient. You need a slightly small value. So in this case, I'm going to choose a 0.4 and put it inside the test. I will be getting a negative value. So negative value translate to down arrow. So if you follow the shape of the arrow, you will be able to conclude that this is a minimum point. So even though it's a little bit troublesome, there are some students who like this because visually you can see it. You do not need to kind of memorize. Of course, the troublesome part is I need 2 tables. So I need to test another point. So when I need to test another point, I make sure I got the 3 values first. I need a little bit bigger value. Okay, slightly bigger than -3 is -2.9. Don't go and put -3.1 because -3.1 is actually smaller than -3. So on the right side, it is a value that is slightly bigger. On the left side is a value that is slightly smaller. Then where will all the value go to? All the value will go to dy dx. Okay, so this will go to dy dx. Obviously, it will give you a 0. This will go to dy dx again. So when you go to dy dx, in this case, you will get a negative. Okay, this go to dy dx. Punch calculator in your dy dx. You should get a positive value, so it's going up. So by the shape of the arrow, you can tell that it's actually a maximum point. The conclusion should be the same as the second derivative. So for a given question, I can do it by the first derivative, I can do it by the second derivative. Okay, so later on, the second derivative test and the first derivative test will be extended to maximization and minimization problem. So we will use the second derivative or first derivative test to test nature, and we will extend it to the maximization and minimization problem. Okay, so look through it. Make sure you are able to execute stationary point. Make sure you know how to execute the second derivative test and the first derivative test to tell the nature.